All right, so here we've got solving equations and sometimes evaluating those functions. So here we're going to look at some examples, just review of equations, and we're going to solve these out and work these out together before we practice. All right, so the first one says 6 parentheses, that means 6 times t plus 5 is equal to negative 36. And one thing that I always do kind of when I first start solving equations is I put a line down that equal sign. So I know that whatever value over here, this value on this side needs to equal this value on this side. All right, they have an equal relationship. So it's kind of like a seesaw back in the day. All right, and it's equally balanced. So one side is obviously not tilted up or down like that. So each side has to be equal. So if I subtract one thing or add one thing to one side of the seesaw, in order to keep it level, in order to keep it balanced, I need to subtract or add the same thing on the other side. And the same goes with multiplying and dividing. So one way of working this out, you may say, all right, coach, well, you need to distribute. Okay, so when we distribute, you get that 6 times t is 6t plus 6 times 5 is 30. And then that's equal to a negative 36. Okay, so now I need to get just my variable on one side. I want to end up with 1t, and then I just want only a single number over here on this side. So I'm going to take the single number, 30. All right, I'm going to subtract it. So I get that 6t is equal to, what is that, negative 66. And then we see that, all right, when we divide by 6, okay, I divide by 6, I get that t is equal to negative 11. All right, so that means that if I plugged negative 11 into this function, all right, I'm going to kind of come over the side over here. If I plug negative 11 in here, let's see if that actually equals negative 36. Okay, well, that's negative 66, all right, plus 30. Okay, and look, I mean, it's kind of counterintuitive because that's in our problem over here. All right, so we have negative 36 equals to negative 36. Okay, so let's move on to the second example. So number 2 says that 3m divided by 5 is equal to 6. All right, so just generally speaking, I know that whatever this is on the top, all right, divided by 5 has got to give me 6. Okay, so I know that what number divided by 5 does give me 6. All right, and I know that 30 is going to give me 6. Okay, so some people will think about this some will say they know that 3m has got to equal 30, and thus when I divide by 3, m has got to equal to 10. Okay, but maybe some of us don't think about it that way. All right, we want to solve it the old school way. And so I know that, hey, the opposite of dividing by 5 is multiplying both sides by 5. And so that'll get these 5s here to cancel. And so then that gives me 3m is equal to 30, just like what I had up here a second ago. All right, and then we have that m is equal to 10. Okay, so m equals 10 is the only thing that's going to make that equation be a true statement. All right, so let's look at number 3. Okay, this one has 2 sets of variables. So j is here. I have a negative 5. All right, I have a positive 66, and then a negative j here. And remember, our whole goal is at the end of this, I want to get 1j is equal to something with a number in it. Okay, and so we're gonna add or subtract or try to figure this out and manipulate this equation. Okay, well, I'm going to move. I notice that I have a negative j, so I'm going to move this negative j over by making it positive. Okay, and that's going to give me 9j over here minus 5 is equal to 67. All right, and then again, I can see that I can move this 5 over. I can go plus 5, and I have that 9j is equal to, what's that going to be, 72? All right, and then when we divide by 9, all right, we get that j is equal to 8. And so plugging that in, all right, that's going to give us a true statement. We could go back and check that. All right, we could check that 8 times 8 minus 5, is that the same as 67 minus 8? All right, and so you have 64 minus 5, which is 79. 67 minus 8, which is 79. You get 79 equals 79, and so this equation checks out. The solution, the only solution is 8. Okay, looking at number 4. All right, kind of the same idea here. What I'm going to do is let's just add 1 to this side, add 1 to this side. I've got 5m plus 4 is equal to 9m, and then I'm going to subtract 5m from both sides. Subtract 5m, and we get that 4 is equal to 4m. Okay, when you divide by 4, you get that m is equal to 1. Okay, so in this example, 1 is the only thing that makes this equation true. All right, let's look on to number 5. Okay, so distributive property here. I notice that 2 times 3 is 6x. 2 times negative 6 is a negative 12. And then 3 times 2 is a 6x. 3 times negative 4 is a negative 12. All right, so I take a step back and I look. This side of the equation is equal to this side of the equation. All right, and so, okay, we have both sides are equal, so it doesn't matter what I put into one side of the equation, I'm always going to get the same answer. Like if I said x equals 3, 6 times 3 minus 12 is always going to be the same as 6 times 3 minus 12. All right, so I already know right now, I can tell that this one is going to have infinite solutions. All right, and so we would be able to stop there. Okay, but maybe you kept on going. Maybe you still had your 6x minus 12, and that was equal to your 6x minus 12. All right, then you tried to solve it like we always do, okay? And so I got plus 12, so I get 6x equals 6x. All right, and again, maybe I didn't stop there. I didn't realize that they were the same on both sides, which means that it's infinite. It doesn't matter what I plug in for x. Okay, and then maybe I subtract 6x, subtract 6x. All right, and I got 0 equals 0. Okay, which is true. You can have 0 equals 0, and that means I can plug anything in, which is going to tell me that my answer is an infinite solution problem for that equation. Okay, let's look at number 6. So number 6 says negative b plus 4b is equal to 8b minus 1b. All right, so if we try to solve this one, let's combine our like terms here. All right, negative b plus a 4b is a positive 3b is equal to 8b minus 1b is 7b. All right, and right away I can already tell that 3b and 7b, there's really only going to be one answer that this could be. If I subtract 3b here, subtract 3b, I'm going to get that's 0 over here. 0 is equal to 4b. All right, and so when we divide by 4, okay, we get that b is equal to 0. So 0 is the only thing that would make this equation a true statement. Okay, let's move on to number 7. It says 3 times g minus 1 plus 7 is equal to 3g plus 4. All right, so let's go about, sorry right there for my dog barking in the background. Let's distribute this. So 3g minus 3 plus 7 is equal to 3g plus 4. All right, and again, I've got some like terms that I can take care of on this side. So I'm going to bring down that 3g. It stays the same. Negative 3 plus 7 becomes a positive 4. And then this, again, 3g plus 4, that stays the same. Well, what do you notice? This looks a lot like number 5. All right, I have the same thing, 3g plus 4 is equal to the same thing, 3g plus 4 over here. And so I already know right away that's going to tell me that this problem is an infinite solution problem. Okay, so there are infinite solutions that we could plug in. All right. Now, what if I try to get you to solve an equation, solve something for just one of the letters, and there's no numbers involved? All right. Well, we can think about this in the same exact way. This is saying V equals pi r squared h, which is the formula for the volume, and we want to solve for h. Okay, so I want to isolate h and get it by itself. Okay, so you can think of this problem as V equals pi times r squared times h. All right, and so a way to undo multiplication is by division. So we can divide by pi and we can divide by r squared to get those to cancel out. And so here we get that V over pi times r squared, that is going to give us h by itself. And so that would be the answer for solving for h in that literal equation. Okay, two more, I promise. We're almost done. So changing gears, flipping gears right here. We got evaluating functions. So don't get confused when you see the word evaluate. All right, it's just a fancy word for plug in. All right, and everybody knows how to plug something in. Okay, and this is just for plugging in to a function. So you could have f of x, or this could say y equals 2x plus 10. All right, everybody's seen that. And so when it says for f of 3, that just means literally we plug 3 in for x. All right, and that is so simple. So don't let the way that this is written, all right, or shown, don't let that confuse you. All right, you are awesome. You can do this, and it's going to be great. So f of 3 is really 2 times 3, all right, plus 10. And so f of 3, okay, is equal to 2 times 3 is 6 plus 10. And so we say that f of 3, or f at the point 3, is equal to 16. Okay, it's just like saying y equals 16 if we were to plug it into this equation up top. Okay, and so the last one we have says f of x equals x squared minus 6 plus x. And we want to plug it in for f of negative 3. And so here, again, I have f at negative 3 is equal to negative 3 squared minus 6 plus negative 3. Okay, anytime I have a variable, I always put that in parentheses when I'm plugging something in, just because it helps me out. Okay, so f at negative 3, all right, negative 3 squared, that's like saying negative 3 times negative 3. All right, and we know that that is going to give us a positive 9. All right, we bring down the minus 6. All right, bring down the plus negative 3. Okay, so we have 9 minus 6 is 3 plus a negative 3 here. All right, and so f at negative 3 is going to give me 0. All right, which is okay. That's a possible solution. All right, so we have ways of solving problems. All right, we have ways of evaluating or just plugging in for the function, all right, and going from there. So you guys are going to do awesome with this, all right? I have full confidence in your ability to do this.